In this learning module, we will discuss how to determine whether two factors or variables are related to each other. This type of research is called non-experimental research. Non-experimental research explores relationships among things. Here are a few examples: information literacy skill and likelihood of plagiarism, standardized math test scores and gender, science test scores and number of hours studied, and graduation and socioeconomic status. Note that in all these cases, the researcher is studying things as they occur naturally, without manipulation by the researcher. That is why this is called non-experimental. The researcher is not experimenting per se, just measuring and observing. There are two types of variables examined in non-experimental research. The predictor variable is the proposed cause or variable that comes first. The outcome variable is the proposed effect or variable that comes second. However, be very cautious in the words you choose to describe predictor and outcome variables, as these causes and effects are only hypothetical. Non-experimental studies do not allow firm conclusions about cause and effect. It is more appropriate to say that a predictor is related to or associated with an outcome than to say that the predictor causes or leads to the outcome. In addition, there are terms for the level of measurement involved in a variable. Another term for nominal variables is categorical variable, referring to the fact that nominal variables involve categories. Examples include male versus female, 7th versus 8th grader, tutoring versus no tutoring. In contrast, a continuous variable is another term for interval or ratio variable, that is, something that has a place on a range of values. Examples include test score, satisfaction rating, and GPA. Now that we have the terminology straight, let's review some types of non-experimental studies. The most common involves looking at the relationship between two or more continuous variables. For example, is there a relationship between star reading scores, a continuous variable, and star math scores, a continuous variable? Also common is the exploration of the relationship between one continuous variable and one categorical variable. For example, is there a relationship between number of hours worked after school, a continuous variable, and ethnicity, a categorical variable? Occasionally, researchers will look at the relationship between two or more categorical variables. For example, is there a relationship between passing status, that is, pass versus fail, categorical variable, and special education status? For example, learning disabled versus emotionally disturbed, also a categorical variable. A study that looks at two or more continuous variables is sometimes called correlational research. This involves measuring variables and then calculating a statistic that represents the strength of the relationship between them. The most common correlation statistic for this type of study is Pearson's R. If the variables are positively related, as one variable increases, the other increases. If the variables are negatively related, as one variable increases, the other decreases. If the variables are not related at all, one variable will not change as the other changes. Here is an example of a positive correlation. On the y-axis is the student's test score. On the x-axis is the number of hours that the student studied. As expected, the more a person studies, the higher his or her grade is. This is represented by the upward slope, also called a regression line. Here is an example of a negative correlation. On the y-axis is the student's test score. On the x-axis is the number of days that the student was absent during the week. Also, as expected, a higher number of days absent was associated with a lower test score. Here, the regression line slopes downward. Here is an example of two variables that have no correlation. The y-axis represents the student's test score, and the x-axis represents the number of friends that the student has. As you can see, there is no rhyme or reason to student scores. Some students with many friends perform well, others with few friends perform well, some with few friends perform poorly, and some with several friends perform poorly. The fairly flat line indicates that there is no relationship between these variables. Pearson's R, the statistic most commonly used for this type of design, is called a correlation coefficient. Correlation coefficients range from -1 to +1. A correlation of 0 indicates no relationship. Correlation coefficients between 0.10 and 0.29 represent a small relationship. Correlation coefficients between 0.30 and 0.49 represent a medium relationship. And correlation coefficients equal to or greater than 0.50 represent a large relationship. The sign, positive or negative, indicates whether the relationship is positive or negative. Note that R can also be evaluated in terms of its statistical significance, which in this case indicates that the correlation obtained in the sample is likely to reflect a true correlation in the population. Now let's look at studies that involve one continuous variable and one categorical variable. These are sometimes called causal comparative research. They involve measuring outcomes for two or more pre-existing groups, calculating the mean for each group, and then calculating a statistic to determine whether there is a difference between the group's mean scores. The most common statistic for this type of study is students T, unpaired. Once students T is obtained, a statistical calculator will indicate whether the statistic is significant, which means that the difference between the means obtained in the sample is likely to reflect the difference that would be obtained in the population. In this type of research, there could be some confusion, as we are not measuring the strength of a relationship. Rather, finding a difference implies that there is a relationship. For example, a difference between boys and girls in mean test scores implies a relationship between gender and test scores. However, as with studies that use two continuous variables, this does not mean that gender causes difference in test scores, just that gender is related to test scores. There are many things that might be the cause of this difference. These other explanations cannot be ruled out. Now note that the relationship is not described as positive or negative. It is simply described as a difference between the groups. Given the fact that we are looking at relationships in terms of group differences here, be careful of how you present the results. For example, if you find a significant difference between the boys' test scores and the girls' test scores, it would be correct to say, there is a difference between boys' and girls' test scores, or girls scored higher than boys on the test, or there is a relationship between gender and test scores. It would be incorrect to say, gender influenced test scores, or there is a relationship between boys' and girls' test scores, or there is a difference between gender and test scores. Try to be mindful of what variables you are looking at and what the scores are telling you. Here is an example of a graph that illustrates the relationship between gender and test score, as demonstrated by a clear difference between girls' mean test score and boys' mean test score. Again, the relationship isn't positive or negative. It is just a relationship manifested in girls scoring higher than boys. The final type of non-experimental study we'll discuss involves looking at two categorical variables. At times, researchers may want to know if the composition of two or more groups differs. For example, is the ratio of girls to boys in Class A roughly equal to the ratio of girls to boys in Class B? This involves counting the number of people within each category and calculating a statistic to determine whether the two groups have equal ratios. The most common statistic for this type of research is the chi-square. Here's an example of a data table that we would use to calculate chi-square. There are two variables, gender and class, and each variable has two levels or options. For gender, these would be boy versus girl. For class, these would be A versus B. Both classes have 20 students, obtained by adding up the columns for each row. Class A has 10 girls and 10 boys, while Class B has 5 girls and 15 boys. In Class A, the ratio of girls to boys is 50-50. That is, 50% of the class are girls and 50% of the class are boys. In Class B, the ratio of girls to boys is 25 to 75. That is, 25% of the class are girls and 75% of the class are boys. The test statistic chi-square would indicate whether these two ratios are significantly different from each other. Of course, they are literally different. The numbers are not identical. But remember that we typically want to say whether differences are meaningful relative to the population. If there is a significant difference in ratios, we would say there is a relationship between gender and classroom, or there is a difference between the classes in terms of gender ratio. Given that non-experimental studies do not answer the critical question of what causes certain outcomes, why conduct them at all? Well, some variables cannot or should not be experimentally manipulated. We cannot manipulate gender, nor should we experimentally manipulate things like school quality. We have to study these things as they exist naturally. Furthermore, non-experimental studies provide information that is a useful starting point for understanding factors that contribute to outcomes. Once we have non-experimental data, we can better determine whether to conduct experimental studies if such studies are possible. In contrast, if no relationship between variables exists, it might not be worthwhile to invest in studying these variables experimentally.